at the end of today's tutorial, we're going to understand this question number 2. And the first one says, list 2 physical properties used as criteria for purity of substance. We are looking at JAMB and WAEC GCE question on chemistry separation technique topic. Now, these 2 physical properties used as criteria for purity of substance. What we are talking about here is pertaining to before you can be able to separate a mixture, you should be able to know the type of purity or the type of physical state of those substance, physical or chemical state of the substance. So these states or criteria that we use for the purity of substance, number 1 is the melting point, number 2, the boiling point, number 3, the freezing point, and the last one, the density. Number 1 question answer. Now this second question, answer, let me know the answer in the comment section. It says the purity of a solid sample can best be determined by its A, boiling point, B, melting point, C, conductivity, D, solubility. Let's know the answer in the comment section. The third one I'm going to answer says give 2 characteristic features of boiling. Only 2. Now boiling, these answers are number 1, boiling occurs at a specific temperature. Number 2, during boiling, bubbles are formed. Vapor bubbles are formed during the boiling. Number 3, what can we say? The vapor pressure during boiling is equal to the atmospheric pressure. All right. You could also include that boiling occurs throughout the medium of water. So if this is boiling, the boiling is going to occur throughout what medium? Question answered. Number 4, list 3 uses of fractional distillation in industry. What's a fractional distillation? We have distillation, we have fractional, we have simple distillation, we have fractional distillation. Now, fractional distillation is a compressed type of separation technique, whereas whereby we identify the specific boiling point of the constituent. For example, crude oil has various substances in it. We have fuel, we have kerosene, and so many on that you can find on crude oil. Now, for industry to be able to separate this constituent from crude oil, they are going to use fractional distillation. This is going to be very, very easier, whereas the fractional distillation is going to be happening based on the boiling point of those constituents, the kerosene and the so on that are found on crude oil. Now, at that specific boiling point, at that specific temperature that it is going to boil, let's just make a rough sketch over here. This is a retor stand, and I'm not drawing to scale or perfect drawing, please. May not be correct drawing, but just to show you how. Right now, this here, from here back to another conical flat. Let me just draw a rough sketch. May not be correct. All right. So if you have seen this somehow in your book, not correct, I repeat. This is going to be the mixture of what you have. Now, when it is boiled, let's say this is crude oil. If the temperature is about 50 degrees Celsius, and one of the constituents or one of the constituents on this mixture boils on 50 degrees Celsius, that particular substance will start to evaporate from here. They start evaporating. Now, how we notice is that there will be a thermometer here that measures the temperature. The thermometer will be fixed here. Now, as it is evaporating, it's going to flow through this part. At this point, it's going to turn back to liquid and now fall in back to this particular conical flask. Now, as that temperature is increasing, we're going to remove that particular constituent, pour it away, and then put it again. For the temperature to increase, another substance that has to boil at that particular temperature start boiling and it starts evaporating. So if there are 3 substituents on that particular mixture, we should have maybe, if the first one boils at 50, like I said, the second one may be 75 and 100 degrees Celsius. And most times we will have more than 100 degrees Celsius. And then at this temperature, we remove the first one. The second one will start boiling and then will also be evaporating. We remove it from here. So this is under what? fractional distillation. But here we're asked to list three uses of fractional distillation in industry. The first one is separation of what? Crude oil. The second one is obtaining of liquid oxygen. Now, the third one, let me know on the comment section what the third use of what? Fractional distillation. There are so many other uses. The fifth one says, list three methods of separating a solid from a liquid. Three methods of separating a solid from a liquid. Mind you, we have solid liquid mixture, we have solid solid mixture, we have liquid liquid mixture, and we have colored mixture, which is, you can say that it is liquid colored mixture. Now, how can we separate this? How we can separate a solid from a liquid? There are so many ways. Number one is through filtration. Number three is through evaporation to that dryness. Number three is decantation. Number four, you can choose to use crystallization. You can choose to use fractional crystallization. You can choose to use um, simple precipitation, and so on and so forth for the what? Separation of solid from a liquid. The last one says, list two methods that can be used in separating a mixture of iron filling and iodine crystals. Now, when you're looking at this two is a solid, solid mixture. So iron filling is a solid, iodine crystal is also a what? Solid. Now, when you have a solid, solid mixture, let's say in this container we have the iron filling and then we have the iodine crystals on this container in this form. Now, iron filling can be attracted by a magnet. So if I introduce a magnet on this mixture of iron filling and iodine crystals, magnets are going to work. The iron filling is going to be magneted by this one magnet. So we can use magnetization separation techniques to remove the iron from this mixture. And what is going to remain on this container is the iodine crystal. So the number one is what? Through what? Magnet separation. The next one is based on the fact that iodine crystal has a certain future, in the sense that iodine being a solid, if you hit this iodine, let's say this is an iodine, it's going to change automatically or directly to vapor. All right, instead of it turning to liquid, it's going to turn to vapor directly. So normally from solid to liquid, from liquid to what? Vapor. But iodine, certain substance, changes from solid to liquid. This situation or this phenomenon is known as what? Supplying. So iodine supplies while heating. Hence, if we can now put the mixture, have the mixture like this, and we are going to put a wire gauge on a tripod stand, we are going to heat it. Now, the iodine crystals we on heating is going to be what? Evaporated. Remaining what? The ion filling. So the ion filling remaining here, we can take it. More detailed diagram is putting the evaporating dish here, and then we are going to invert the funnel at this point. Invert the funnel. This is the mixture. On heating, the iodine crystal will change automatically to what? To vapor, and it's going to be found here. What is going to remain here is just the what? Ion filling. Now we're going to what? Turn this funnel upside down. We have the what? Iodine crystal, and we're going to have the ion filling remaining here. Now, on cooling, the iodine crystal that turned to vapor, we also turn back to what? Solid. So that is now the question I asked you to find is question number 2. Let me know in the comment section. If you have any topic that's very difficult for you, let me know in the comment section. I'm going to make it as soon as possible. Thank you. Welcome back to Lecture 4 on Academy.